12 drones, 1 warship, and a bridge crew that had no idea what was coming low across the water. This is the story of how Ukrainian naval planners took a lesson from a distant strait, adapted it to their own sea, and executed a strike that proved something the Russian Black Sea Fleet had refused to accept. Nowhere is safe. Not when you're running escort duty for a shadow fleet tanker carrying sanctioned oil. Not when your radar is on. Not when you think you've seen this threat before. I'm your host at East Alert, where we analyze the battles that change wars. What you're about to hear is a reconstruction of a naval operation that combined drone swarm tactics, maritime intelligence, and split-second timing in a way military analysts are still studying. The details come from Ukrainian operational summaries, satellite imagery analysis, OSINT tracking of vessel movements, and intercepted communications that captured Russian crew reactions in real time. By the end of this, you'll understand exactly how Ukraine turned a distant naval confrontation into a tactical blueprint, and why the Russian Navy's Escort doctrine is now one of the most exposed weaknesses on the Black Sea front. But first, picture a radar screen. A single contact. Small. Moving fast. Bearing 270. A Russian naval officer on the bridge of an escort vessel leans forward and studies the return. The signature is consistent with a surface drone. They've seen these before. Protocol is clear. Engage at distance, activate defensive countermeasures, maintain station relative to the tanker. What the officer does not know, what no one on that bridge knows, is that the single contact on the radar is not alone. 11 more are running dark, low, and fast below the radar horizon. And they are already inside the defensive perimeter. To understand why this operation worked, you need to understand where the idea came from. Not from a training manual, not from a NATO briefing packet. From a body of water 8,000 kilometers away, where a confrontation between the United States Navy and Iranian fast attack craft had been playing out for months with increasing intensity. The Strait of Hormuz. 21 miles wide at its narrowest point. 20% of the world's oil supply passing through it daily. For years, Iranian Revolutionary Guard Corps naval units had been refining a specific tactic: swarming. Multiple fast-moving surface contacts, coordinated but not simultaneously visible, converging on a target from different vectors. Not designed to overwhelm a frigate with firepower. Designed to overwhelm a crew with decision-making. The tactical problem the Iranians had identified was not armor. It was cognition. A warship's defensive systems can track multiple threats simultaneously. The crew operating those systems cannot process unlimited inputs without degradation. When threats multiply faster than a crew can categorize, prioritize, and engage them, decision quality collapses. Gunners hesitate. Targeting priorities conflict. Fire control officers contradict each other. In the Hormuz scenario, the U.S. Navy had adapted its doctrine to counter this: distributed engagement, layered defense. Pre-designated threat sectors, so no single crew position was overwhelmed. Ukrainian naval planners read those after-action reports with enormous interest, because the Black Sea was not the Strait of Hormuz. Russia had no equivalent doctrine refinement. And Ukraine, after losing much of its conventional naval capability in the early phase of the full-scale invasion, had spent 2 years building a surface drone force that had already sunk or disabled a significant portion of the Russian Black Sea Fleet. The swarm tactic was not new to them. What was new was the application against a specific type of target, an escort vessel protecting commercial shipping that Russia was using to move sanctioned oil through waters it increasingly treated as its own private lake. Which weapon is deadlier in this kind of operation? Sea drone swarms, anti-ship missiles, or traditional naval artillery? Comment below with A for swarms, B for missiles, or C for artillery. The target selection process began weeks before any drone entered the water. Ukrainian intelligence services, working in close coordination with partner agencies in Western Europe, had been tracking a specific pattern of vessel movements in the Black Sea. The pattern involved what analysts called a shadow fleet configuration. A large tanker, registered under a flag of convenience arrangement with a third-country intermediary owner, moving crude oil in violation of Western sanctions. Accompanying that tanker on each significant transit was a Russian naval escort. Not a full warship group, usually 1 or 2 vessels, patrol boats, fast attack craft, occasionally something heavier. The shadow fleet tanker in question had been observed on multiple transits. Intelligence analysts had cross-referenced its AIS transponder data when it was transmitting, which was not always, with satellite imagery of its actual position. The correlation was consistent with a vessel deliberately masking its location during portions of its route. The escort assignment rotated, but the pattern held. A Russian Navy vessel would pick up the tanker at a transfer point, shadow it through the most sensitive portion of the transit, and peel off when the tanker reached waters considered secure from Ukrainian interdiction. Ukrainian planners assessed the escort as a legitimate military target. The vessel was a commissioned warship of the Russian Federation Navy, operating in active service, providing direct support to an operation that sustained Russian war finances. That assessment was legally and militarily clear. The tactical question was harder. How do you neutralize an escort vessel that knows Ukrainian sea drones exist, that has seen them before, that has defensive systems designed to detect and engage surface threats, without losing your entire strike package to defensive fire before a single drone reaches effective range? The answer, as it turned out, had been written on a whiteboard in a U.S. Navy analysis cell studying events in the Strait of Hormuz. You don't send the drones in a single wave. You send them in layers. Stay with me. What happens in the next 18 minutes destroys a warship, exposes a shadow fleet operation, and changes how Russia plans every Black Sea escort mission going forward. The operational concept Ukrainian planners developed was built around a core deception principle borrowed from the Iranian swarm model, but modified for Ukraine's specific naval drone inventory. Phase 1. A single drone on a direct intercept course toward the escort vessel. Visible. Trackable. Behaving exactly as Russian crews had been briefed to expect a Ukrainian surface drone to behave. The intent was not to hit anything with the first drone. The intent was to trigger the defensive protocol, consume the crew's attention, and establish in the minds of the bridge team that they understood the threat they were facing. Phase 2. 11 additional drones approaching from 3 different vectors, running at wave-level altitude, barely above the water surface, to minimize radar cross-section and exploit the shadow effect of sea state against lower-frequency detection systems. These drones would not transmit. Their navigation was pre-programmed to the final approach phase, with human operators maintaining a passive monitoring role until the final activation window. Phase 3. Coordinated attack run timed to begin at the moment the escort's defensive fire was committed against the primary decoy drone. The timing window was calculated to be approximately 90 seconds. The point at which the escort crew, having identified and engaged the lead drone, would begin assessing whether the threat was neutralized before looking for additional contacts. 90 seconds. That was the gap Ukrainian naval planners had to work with. But here is where the first obstacle emerged, and it nearly collapsed the operation before a single drone left Ukrainian territorial waters. Weather. A low-pressure system moving across the Black Sea in the days before the planned operation brought sea states that exceeded the operational envelope for several drone variants in the strike package. Ukrainian engineers had been working on hull modifications to improve rough water performance, but those modifications had not been fully validated. Testing showed a significant failure rate in swells exceeding 1.2 meters. The forecast called for 1.4. Strike commanders faced a decision: delay and risk losing the intelligence window on the target's transit schedule, or proceed with a modified package that reduced the swarm count from 12 drones to 9, substituting 2 more robust variants for the 3 most sea state-sensitive units, and accepting reduced attack density on 1 approach vector. They chose to proceed. 9 drones, 3 vectors, 1 window. The target was a patrol vessel operating as escort for the Shadow Fleet tanker. Russian naval designation placed it in the category of small missile ship, lightly armored but equipped with a close-in weapons system, anti-air radar, and a crew of approximately 60 personnel. Its defensive doctrine, as reconstructed by Ukrainian analysts from observed exercises and intercepted fleet communications, relied on early threat detection, distance engagement, and the assumption that a surface drone attack would present as a single or at most dual-contact threat. The doctrine had never been tested against a 9-drone coordinated swarm running 3 independent approach vectors. It was about to be. The operation launched in darkness. Ukrainian drone operators, positioned at a secure coastal facility, began the deployment sequence at the pre-calculated optimal time. The sea state had moderated slightly from the forecast, 1.1 meters in the operational area, which was manageable for all 9 drone variants in the modified package. The lead drone, call it Alpha, launched first. It was given a direct approach course. No evasion programming. No deception maneuvers. A clean, trackable, predictable approach that any competent naval radar operator would identify and report within minutes. The 8 support drones launched in sequence over a 40-minute window, fanning out to their respective approach vectors and entering a low-speed holding pattern at standoff range while Alpha continued its approach. The holding pattern kept them below the engagement threshold of the Escort's radar at that distance, not invisible. Below the threshold at which a crew tracking an incoming threat on one bearing would instinctively expand their search. Alpha crossed into detection range at precisely the moment Ukrainian planners had calculated. The Escort bridge picked it up. The crew went to action stations. How many drones did Ukraine deploy in the final attack wave? A, 6B, 8C, 9. Answer coming at the end. From this point, the reconstructed timeline becomes very specific. Ukrainian signals intelligence was monitoring the Escort's communications. What followed has been characterized by analysts as a textbook example of single-threat tunnel vision. The cognitive vulnerability the entire operation was designed to exploit. The bridge officer reported 1 contact. The defensive system was cued to engage. The close-in weapons system went active. Fire control radar locked onto Alpha. 47 seconds after Alpha was first detected, the Escort opened fire. Alpha was hit. For 11 seconds, nothing else happened on the bridge of that Escort vessel. The threat had been identified, engaged, destroyed. The protocol had worked exactly as designed. Those 11 seconds were the most expensive of the entire operation, because in those 11 seconds, 8 drones crossed the radar horizon. The fire control officer saw the returns appear almost simultaneously. Not almost simultaneously. Simultaneously. 8 new contacts, 3 different approach vectors, all inside 3,000 meters. The Escort had 1 close-in weapon system. 1. It could track a single priority target, or it could be cycled manually between threats. But cycling had a reacquisition time. And reacquisition time, multiplied by 8 threats at closing speed from 3 different directions, produced a single mathematical outcome. The system could not service all targets before they arrived. Intercepted communications from the Escort in the moments following reveal a degree of bridge confusion that Ukrainian analysts described as consistent with crew cognitive saturation. Multiple officers issuing contradictory targeting instructions. The close-in system cycling between contacts, achieving partial engagements but not confirmed kills on any single drone before new threats demanded reorientation. 1 drone from the port vector was destroyed at approximately 800 meters. 1 drone from the starboard vector was destroyed at approximately 1,400 meters. The remaining 6 drones, 2 from port, 2 from starboard, 2 from the bow vector, reached effective attack range. 6 drones against a lightly armored patrol vessel. Subscribe to East Tailored if you want to understand how modern warfare actually works. Not the headlines, not the press releases, the actual mechanics of how fights are won and lost at sea. The detonation sequence took 22 seconds. Impact 1. Bow section, starboard side. The drone struck at the waterline on the forward hull. The warhead detonated against the hull plating, punching a significant breach. Water began entering the forward compartment. Impact 2. The superstructure amidships. This strike hit the bridge area. Ukrainian naval warfare specialists assessing the impact later noted that this hit would have immediately degraded the vessel's command and control function. If the bridge team was still attempting to coordinate defensive fire after Impact 1, that coordination capability was now severely compromised. Impact 3. The engine room area, port side aft. The strike was lower on the hull than ideal, but the detonation still produced catastrophic damage to propulsion systems. Propulsion failure. The vessel was dead in the water. The remaining 3 drones impacted in sequence. Amidships. Superstructure again. And 1 strike at the stern that OSINT analysis of subsequent satellite imagery suggested may have reached an ammunition storage area, producing a secondary explosion visible in commercial satellite passes hours later. In 22 seconds, the Russian escort vessel went from a functioning, combat-capable warship conducting standard patrol duties to a dead, burning platform taking on water from multiple breach points. The Shadow Fleet tanker, which had been observing the engagement from approximately 3 nautical miles, immediately altered course and attempted to increase speed. Without its escort, it was now a large, slow, radar-trackable vessel operating in waters where Ukraine had already demonstrated it could reach anything it chose to target. Ukrainian maritime surveillance, which had been maintaining continuous coverage of both vessels throughout the operation, tracked the tanker's course change in real time. The the tanker transmitted a distress signal within 14 minutes of the Escort's destruction. Not because it was damaged, because its captain had made a clear assessment of the situation. The Escort was gone. The waters were Ukrainian, and a loaded tanker full of sanctioned Russian crude has no armor. What do you think? When a sanctioned oil tanker loses its military escort in contested waters, does it bear responsibility for enabling the conflict it was profiting from? Drop your answer in the comments. We read every one. The aftermath of the strike was documented across multiple intelligence streams over the following days. Satellite imagery confirmed the escort vessel was no longer operational. Thermal imaging from commercial satellites detected residual heat signatures consistent with an ongoing fire in the hull section during a window several hours after the strike. By the next satellite pass, the vessel had been taken under tow. Its ultimate fate was not immediately confirmed, but subsequent tracking of Russian naval repair facilities indicated the vessel was assessed as a total loss or requiring depot-level repairs that would remove it from Black Sea service for an extended period. The tanker, after its distress signal, reversed course and returned to a Russian-controlled port. The cargo. Ukrainian intelligence estimated approximately 80,000 metric tons of crude oil did not reach its intended destination. The financial loss to the sanctioned shipping network, including the value of the cargo, the vessel downtime, and the loss of the Escort itself, was estimated by analysts tracking the Shadow Fleet operation at between $60 and $90 million across the full supply chain disruption. Ukrainian general staff reporting on the operation emphasized several specific outcomes. First, the Escort was a commissioned Russian Navy vessel. Its destruction was a direct military loss to the Russian Federation Navy in the Black Sea theater. Second, the Shadow Fleet operation it was supporting was disrupted, not just for this transit, but for the pattern. Every subsequent escort assignment in that operational area would now require accounting for the possibility of a 9-drone coordinated swarm attack against which single-CIWS coverage was demonstrably insufficient. Third, the operation was conducted without the loss of a single Ukrainian operator or a single Ukrainian military asset beyond the drones themselves. The cost calculus was extreme: 9 drones, against a warship and a supply chain operation worth tens of millions of dollars. The cost-exchange ratio, a metric Ukrainian commanders had become expert at calculating after years of fighting an adversary with far greater mass, was extraordinarily favorable. Combat footage captured by drone operators on the approach run, along with visual data transmitted by surviving drones as they closed on the target, showed the Escort attempting to maneuver. Too late, too slow, and fire from the close-in weapon system visible as streaks of light against a dark water surface. 2 approach drones destroyed. 6 still closing. The imagery was assessed and compiled. It would later be used in training briefs. If you believe tactics win wars, type East Alert in the comments. Russian Navy response to the strike revealed as much through what was not said as what was. Official Russian channels made no announcement about the loss of the Escort vessel. This was consistent with previous Russian practice regarding Black Sea Fleet losses, a pattern of non-disclosure that Ukrainian information warfare specialists had long exploited by releasing their own documentation before Russian narratives could be established. Ukrainian OSINT networks released satellite imagery of the vessel under tow within hours of the strike becoming confirmable. Social media analysis showed the imagery spreading through Russian military blogger channels, a community that had become an increasingly important source of honest after-action reporting within Russia despite official censorship, before any official Russian acknowledgement appeared. The intercepted communications from the bridge of the Escort during the attack, portions of which were later made available to Ukrainian media, became one of the most studied documents in subsequent analysis of the operation. Not because they revealed classified tactical information, but because of what they showed about the human experience of cognitive saturation under multiple simultaneous threats. The recordings captured approximately 4 minutes of bridge audio. The first 47 seconds, from alpha detection to alpha engagement, showed a professional crew executing their protocol correctly and with apparent confidence. The 11-second gap after alpha's destruction was audible in the recording as a moment of calm. Then the returns appeared. What followed those 11 seconds was documented by analysts as exhibiting every characteristic of what military psychologists call decision paralysis under information overload. Multiple voices, contradictory targeting calls, the fire control officer cycling through contacts faster than any of the verbal calls could be completed, the executive officer attempting to impose order with increasingly urgent commands that were acknowledged and then immediately overridden by new threat reports. By the time the first impact hit the hull, the bridge crew was no longer making coordinated decisions. They were reacting, individually, each to the most immediate threat visible to them. The lesson was not subtle. The Escort was destroyed because its crew could defend against one threat they expected, not against 9 threats they didn't. But the story does not end with one warship, because Ukrainian planners had built into this operation something that went beyond the immediate tactical objective. They had designed the operation to be visible, not reckless, not carelessly disclosed, visible to a specific audience. Every Russian naval commander responsible for escort assignments in the Black Sea. The operational design included what analysts later called a demonstration component. The choice of attack vectors, the timing, the visible delineation of 3 separate approach corridors. These were not random. They were selected to produce imagery and communications intercept that would be pedagogically clear to any professional naval analyst assessing what had happened. The message was direct. Ukraine had the capability to run coordinated multi-vector swarm attacks against escorted vessels. It had the intelligence capacity to identify escort assignments before they began. It had the range to reach escort tanker formations anywhere in the operational area. Assign a single-CIWS escort to protect Shadow Fleet tankers, and you were assigning that escort to its destruction. What would NATO have done differently? Would Allied doctrine have survived a 9-drone multi-vector swarm against a single-CIWS platform? Comment your analysis below. The Russian Navy's response to this tactical reality played out over the following weeks in ways that were trackable through open-source intelligence. Escort assignments became more cautious. Vessels assigned to Shadow Fleet protection began operating with greater standoff distance from their charges. Russian naval patrols in the northwestern Black Sea, the area of highest operational risk, showed increased coordination with aviation assets. Helicopter coverage of vessel movements, which had previously been intermittent, became more consistent. All of this had costs. Helicopter sorties consume aviation hours and maintenance capacity. Increased naval patrol, tempo increases, hull wear, and crew fatigue. Greater standoff distance between escort and charge reduces the escort's ability to intervene rapidly if a fast-moving drone breaks through defensive coverage. The strategic effect of the operation extended far beyond the single vessel destroyed and the single tanker turned back. It forced a defensive posture change across the Russian Black Sea naval presence, a posture change with resource implications for every subsequent operation. Ukrainian planners assessed this as the intended outcome. The naval drone program that made this operation possible had been years in development, accelerating dramatically after the full-scale invasion demonstrated both the strategic necessity and the operational viability of attacking Russian naval assets with autonomous surface platforms. The early strikes. The attack on the flagship Moskva, subsequent strikes on Black Sea Fleet vessels in Sevastopol harbor, had been achieved through a combination of anti-ship missiles and early-generation surface drones. Each attack had generated lessons. Each lesson had been incorporated into subsequent drone design, operational doctrine, and targeting methodology. By the time this escort swarm operation was executed, Ukraine was operating what military analysts described as a mature surface drone capability. Not experimental, not ad hoc. A systematic program with dedicated operators, established logistical support, tested variants for different operational environments, and a doctrine that had been validated through multiple successful engagements. The doctrine was not without failures. In the period leading up to this operation, Ukrainian drone teams had attempted 2 similar multi-vector swarm engagements that had not achieved their intended results. In the first, electronic warfare interference from a Russian EW platform operating at closer range than expected had disrupted drone navigation systems during the final approach phase. 6 of 8 drones had lost course coherence and missed their targets. In the second, weather conditions had worsened faster than forecast, producing sea states that exceeded the operational envelope for 3 of 5 strike drones, causing 2 to swamp and 1 to turn back. Both failures had produced analysis. Both had produced modifications. The navigation system was hardened against the specific frequency profiles of the EW platform that had interfered with the first attempt. Hull stability improvements and modified ballast configurations addressed the sea state sensitivity that had hampered the second. The escort swarm operation was, in a meaningful sense, the 3rd attempt at a concept that had failed twice. Success was not inevitable. It was engineered. This is a principle Ukrainian military engineers and operators repeat in their own after-action culture. Innovation does not mean first attempts that work. Innovation means learning faster than the adversary can adapt. The Russian Navy learned slowly. Each time Ukraine demonstrated a new capability, The Russian response was incremental. Additional radar coverage here, slightly modified escort doctrine there, eventually a new set of procedures for escorted vessel operations. But each adaptation came after the loss that necessitated it, not before. Russian naval doctrine in the Black Sea was, according to Ukrainian and Western analysts, consistently reactive. Ukrainian naval operators were consistently generative. They were not waiting to see what Russia did and responding to it. They were developing new capabilities, testing them operationally, failing and refining and trying again, faster than Russia could assess what had happened to them. That asymmetry was the operational context for the escort swarm strike. And it raises a question that analysts had been circling for months without a clean answer. How long can a naval drone campaign sustain strategic effect against an adversary that has many more conventional naval assets to absorb the losses? The answer Ukrainian planners had developed was not about attrition. It was about access denial. Each Russian vessel lost or damaged reduced the fleet's ability to project power in the Black Sea. But more importantly, each operation that demonstrated Ukrainian reach into previously assumed safe operational areas changed Russian naval calculus about what was safe and what was not. The Shadow Fleet escort mission was not a peripheral operation. It was a revenue operation. The oil moving on that tanker, through the sanctioned network it was part of, contributed to the Russian war budget in a direct and calculable way, disrupting that flow. Not just once, but as a systemic pressure on the Shadow Fleet's operational confidence, had economic consequences that reinforced the military ones. A tanker that cannot safely transit because its escort can be destroyed costs money. A shipping operator who cannot find an escort willing to take the assignment, because escort crews now understand what Ukrainian swarms can do to them, loses revenue. An oil buyer who cannot receive consistent deliveries eventually finds alternative suppliers. The war economy pressure was the strategic layer underneath the tactical one. Ukrainian planners had always understood this. The Black Sea Fleet campaign was never only about sinking warships. It was about making the Black Sea a contested space where Russian assumptions about maritime security could not be maintained without prohibitive cost. The escort swarm operation was the clearest demonstration to date that this contested space strategy was working at the level of individual commercial military hybrid operations, not just conventional fleet engagements. In the hours after the operation, Ukrainian drone operators reviewed their sensor data. Alpha, the decoy drone, was gone. Hit by the escort's close-in weapon system at the range calculated. Its sacrifice was the operational foundation the entire swarm depended on. Of the 8 support drones, 2 were destroyed in defensive fire. 6 reached the target. Of those 6, 5 produced confirmed hull impacts. The 6th detonated against an external fitting on the superstructure that produced less structural damage than a hull strike but contributed to the fire and system damage burden. 5 hull strikes on a lightly armored patrol vessel. There was no survivable scenario for that ship. The quiz answer: Ukraine deployed 9 drones in the final modified attack wave. Not 6, not 8, 9. Reduced from the original 12 due to weather constraints. Of those 9, 1 was the decoy that triggered the defensive protocol. 2 were destroyed in defensive fire, and 6 reached the target and produced impacts. The decision to modify the package from 12 to 9 rather than delay the operation preserved the intelligence window on the target's transit schedule. It was the right call, though it required accepting a reduction in attack density on one of the 3 approach vectors. Was the decision to proceed with 9 drones instead of delaying for better conditions the right choice? Would waiting for the full 12 drone package have produced a cleaner result? Or would the intelligence window have closed? Could the Russian Navy have prevented this with different escort doctrine? 2 vessels instead of 1, or a higher CIWS density platform? And if you were the Ukrainian operational planner, would you have made the same call to run 3 vectors with 9 drones and 1.1 meter swells? Or would you have held for conditions? The Black Sea is quiet in the hours after a strike. The burning stops. The water closes over wreckage. Commercial satellites pass overhead on their orbital schedules, indifferent to what they photograph. But the lesson remains. A warship that has seen 1 drone thinks it understands the threat. A warship that has not yet seen 9 drones from 3 directions does not know what it does not know. That gap between the threat a crew has trained for and the threat that is actually running low and dark across the water toward them is where Ukrainian naval doctrine lives, where Ukrainian planners build, where Ukrainian operators execute. Real battles, real tactics, real consequences. East Alert. Subscribe to East Alert. We break down the battles that textbooks will study for decades. The doctrine is being written right now, in real operations, on a real sea. Understanding it matters for anyone who wants to understand how modern warfare actually works. The Black Sea is quiet now, but the wrecks remain.